If you are looking for ways to improve your project or just be more efficient, then this is a video for you. In fact, the topics covered and this applies to any type of work. Hello and welcome to the Faster Projects channel. My name is Henry Johnson. I've been in the project management field for over 35 years. For the last 15 years, I've been developing and testing methods to accelerate projects. And today I'm going to share them with you. I created a handful of efficiency models to visualize the impact of human behavior. They show how a small adjustment can dramatically increase speed. So why do we have this focus on efficiency? Because it not only reduces cost and duration, but it also significantly reduces risk and uncertainty. It naturally pulls projects faster through the process, and it allows us to capitalize on windows of opportunity. Faster Projects is really a mindset that constantly considers how efficiency affects everything we do. So let's get started. We are showing trains in this presentation because they are a great analogy. To reach full speed, the train and tracks have to be designed for speed. The analogy is that projects and their organizations must both be designed for efficiency. Think about it. How much does your organization influence the project? You're required to follow processes, procedures, and use tools provided by the organization. Now, my experience has been that 80 to 90% of the project efficiency is being driven by these company requirements. Now, efficiency is not something new. We've always been trying to make our processes and tools more efficient. The traditional or waterfall shifted from sequential to parallel or concurrent design to speed up the process. And we added a toll gate technique to stop or shift gears early in the development lifecycle. Agile made great strides towards breaking up the project into smaller segments. That allowed us to get early customer feedback and work on higher requirements first. Lean Startup took the concept of early customer feedback to the ultimate level, where their feedback dictates the future design. What's really different with Faster Projects is starting with a foundation built on efficiency models that are not specific to any method such as Waterfall, Agile, or Lean Startup. In fact, each of these approaches is considered to be a box filled with tools, and projects are not forced on any single mold. So when we design the project, we pull tools from each of these boxes to form a new hybrid approach. When you look at your projects, how would the hybrid approach help you, and what problems can you predict? I found the hybrid approach to be very helpful. In one of my projects, I used the waterfall to predict completion dates and forecast costs on a month-by-month basis. However, sometimes the work was performed using the agile techniques of completing tasks in weekly sprints and holding short daily stand-up meetings. At other times, we used the Lean Startup method to build and design a minimal viable product that was an early prototype we used to integrate and test software. So let's get into these efficiency models and understand what they're really all about. Right now, I'm going to do a brief introduction, and we'll follow that with a closer inspection with some examples. As we go through these models, think about how you can use them to design your project. So let's start with the first one. This is the typical learning curve. This is a traditional learning curve where repeating a task takes less time with each new unit until you reach a plateau. Now, what we've added to the concept to make this a model is how to speed up the learning process and looking at the area under the curve. In the middle, we have something called the value curve. There's a well-documented relationship that exists between the few and how they account for a majority of an outcome. This is also known as the 80-20 rule or Pareto principle. Some examples include 80% of sales coming from 20% of clients, and the top 20% of software bugs can prevent 80% of crashes and errors. Now, for project management, we could apply this principle to requirements for an individual project and to the project portfolio. On the far right is something called the project continuum. Now, the idea of a continuum is not new, and we're always trying to figure out where projects lie in continuum. But this is a new concept that relates the level of knowns with maturity. Others have tried to tie complexity or uncertainty to a continuum, but they are both very difficult to define and measure. Knowns are easier to recognize, And frankly, we're experts at turning unknowns into knowns by learning from others and conducting tests. I want you to notice that this curve is not linear, and the maturity increases quickly when just a few unknowns are transformed into knowns. As the project matures, the effort to transform additional unknowns increases dramatically because they do not have the same value of those initial unknowns. When there are so many unknowns, any information about them reduces uncertainty and increases maturity quickly. These last two models have to do with the organizational behavior and how we manage resources. Organizational behavior. This is a model that I derived from Tony Muschera's safety model in his book called Risk-Based Thinking. Here we see efficiency is constantly decreasing, and that there is a relationship between expected and actual behavior, deferred maintenance, and efficiency. To the far right, we've got the last model. This is a resource optimization. Now this is new. The traditional graph for this relationship is much flatter, especially at the upper end. However, it assumes that demand is the constant, and while we add more resources to the project. Here we consider that resources are constant while demand is constantly changing, and this is much more realistic. So now let's go deeper into each of these models. As we said earlier, the learning curve has two main sections, the learning rate and the area under the curve. One of the most common problems project teams face are familiar tasks, but they are performed so infrequently that people do not remember all of the steps. Is this something you have experienced on your projects? Looking at this typical learning curve, we see that it takes repeated cycles to become proficient. To capture the efficiency between the first time and many, we have several solutions. We can hire an expert to coach or mentor. We can use checklists that guide us through the steps. We can use tip sheets that show us how to perform the task. We can practice the process before we start, or break up the project into smaller segments so we can repeat them to gain efficiency. Now there is the second part to the curve that is not commonly discussed, and that is the gap under the curve. In many situations, the gap is so significant, so even with repeated tasks, the efficiency is still very low. We need to challenge the bottom limit and find ways to drop the time per unit even further. Some solutions include streamlining the process, ensure the tools we use are maintained, bugs removed, errors corrected, etc., automate the process, eliminate the process altogether, and ensure there are no latent errors that cause rework later in the project. So what other techniques have you found useful? There is a natural law of diminishing returns, where having more of something does not have the same value as it did with the first few. Here's an easy example. If you are hungry and order a whole pizza, that first slice has the greatest value, but each additional piece has less and less value because you're becoming full. This is a very powerful concept, but it gets very little press. I think we often find ourselves in contracts to deliver everything on the first try. Now there are times when we need to do this, especially for construction or field installation projects. But I have worked on many projects where working on high value requirements would have saved us lots of time and money. Here's an example. We were working with a box that we had with electronics and it had a 3D model. As it turns out, many of our suppliers only needed files from that 3D model. But the organization still required 2D drawings, so spending months on drawings had very little value, but it cost us several weeks and thousands of dollars. So the opportunity here is that some project requirements are more valuable, and if we look at a portfolio of projects, we also find a small group that provides most of the value. In both examples, we are more efficient with our resources. Now, we can certainly challenge the 20%, but even if it's 50%, this has major implications for efficiency. Now, some of the possible ways of dealing with this or solutions are, we can measure value and prioritize requirements in projects. Now, I've found the Analytical Hierarchy Process, or AHP, and its sister, their prioritization matrix, are great tools for doing this. Both of these use a pairwise comparison method, where we measure both qualitative and quantitative values. A cost or level of resources can also be assigned to the requirements, and that is how we are able to plot a resource benefit graph. Now, in addition, we can use techniques to understand what customers really need. Both Agile and Lean Startup have tools that are very effective with customer feedback. We can also periodically reevaluate, especially reshuffling the deck. We find this mostly in Agile projects, but the technique can be applied to any project. We can also question the benefit of performing tasks with little value. Most of these are associated with standard or prescribed processes, procedures, and tools that really have become outdated. The idea of a project continuum is not new. What is new here is they are using the level of knowns to measure project maturity. Knowns are very easy to measure. We simply ask the question, have we done this before? What I recommend is to walk through the work breakdown structure and mark the unknown elements. Now you can use a color coding of green, yellow, and red for known, partly known, and unknowns to visually represent the number of unknowns. Now the role of the project leader is to design a project that transforms unknowns into knowns. This will reduce uncertainty and risk. So how do we transform the unknowns? A few of the methods include using experts, designing experiments, eliminating elements, and replacing elements with a known. There is a lot of research into the value of small information reducing uncertainty. You can read more about this in Douglas Hubbard's book, How to Measure Anything. There is a natural phenomena where efficiency is constantly decreasing. Now this happens in all organizations. This model here has been adapted from Tony Muschera's book, Risk-Based Thinking. The solution is to frequently monitor our processes by working with employees and fixing the problems. There are two parts to this model. On the top, actual behavior drifts apart from expected behavior as people continue to use shortcuts and workarounds. This leads to problems being kicked down the road that cause rework and delays late in the project. The bottom section represents deferred maintenance of tools, processes, and procedures. People try their best to use the tools and procedures but often find bugs or problems that they have to overcome. This causes rework and high potential for latent errors. Some errors may not be detected until the product is in the field, and this causes significant rework. This is not the traditional resource model that I've seen. The usual model makes an assumption that we have a fixed demand, and as we increase resources, we come to a sweet spot. In reality, resources are difficult to change quickly, but demand is constantly changing. Let's take the example of a simple all-hands meeting found in many companies. People are suddenly pulled off their work for 2 to 3 hours and held in a room to listen to a few managers discuss the business. The demand on these workers is low during the meeting. They are sitting and listening with no work being performed. Efficiency plummets. After the meeting, the pendulum swings the other way as people return to work with fewer hours in the day and with no relief on deadlines. Demand is higher than resources, and again efficiency is lowered as they try to multitask and find shortcuts to finish. Hitting the sweet spot on this model almost never happens. The model is symmetric because demand changes so quickly between high and low. Other examples of rapidly changing demand include adding or removing work from the project, pulling in dates, and people waiting on information to perform their work. If these shifts in demand go unchecked, they eventually cause efficiency to go negative, where we fall behind. We commonly hear this from people saying they moved 1 step forward but fell 2 steps back at the end of the week. Sustained negative efficiency leads to unexpected cost overruns and schedule delays. I hope you found this interesting and has given you ideas on how to speed up your projects or work. More videos on these models are in the works, and they will have some more examples. Thank you for watching this video.